Hi, this is Mr. Adams from Midwood High School, and today we're going to look at properties of covalent and ionic compounds. If you notice right here, I have some salt. Okay, that's my ionic compound. And if you notice right here, okay, it's my sugar. That's my covalent compound. All right, so I got some nice brown sugar and some nice white salt right there. Now, the thing is about covalent compounds, right? They're made up primarily of non-metals, okay? You'll never find a metal, for our purposes, in a covalent compound. So on some occasions, you might see semi-metals with non-metal, but primarily you recognize a covalent compound by having non-metals only. Covalent compounds tend to share electrons, okay? And they tend to be soft compared to ionic compounds. The interparticle or intermolecular attraction between the molecules of covalent compounds is relatively weak compared to ionic compounds, and because of that, they will tend to have low melting points and low boiling points, okay, compared to ionic compounds. So that's what we're doing today. We're comparing covalent to ionic mainly. Let's look at their properties, okay? Covalent compounds form molecules, right? So the thing is, you oftentimes hear covalent compounds being referred to as molecular compounds. So molecular compounds, covalent compounds, the same thing. Covalent compounds are non-electrolytes, meaning that when you put them in water or have them in the molten state, okay, they're not going to conduct electricity for you, okay? So there we go. All right, now an exception, guys, is acids, right? So acids are able actually to conduct electricity. Okay, so we're going to look at ionic compounds. Now, what we like to do, right, is learn by association. So we're going to associate table salt with ionic compounds, okay? We're going to associate sugar with covalent, but know that table salt is not the only ionic compound out there. As long as you're made up of a metal and non-metal, you're going to be ionic for our purposes, right? Okay, so as I said before, metal, non-metal, you recognize ionic compounds, okay? They're made up of positive and negative ions. Remember, we talked about metals losing electrons, forming positive ions, non-metals gaining, forming negative ions. Those guys attract, bam, you have an ionic compound on your hands. They're formed by transfer of electrons to their bonds. Okay, once again, one guy loses, primarily the metal loses, and the non-metal will gain. So transfer electrons is involved, as opposed to sharing in covalent. Ionic compounds tend to be hard and brittle. So when you hit them with some type of force, as we discussed in class, they tend to fracture and they're not malleable. Okay, so you can't put them into shapes. Between the ions, right, there's a very, very strong attraction, right? So that leads to what? That leads to the boiling points and melting points, right, being very high compared to covalent compounds. And ionic compounds are electrolytes. Okay, so what does that mean? That they will conduct electricity in the molten or aqueous phase. And remember, you guys told me in class that molten simply means melted, right? So there we go. So we'll do some experiments in a second. All right, guys, I'm back. I got my trusty flame right here. I hope you can see it. Now what I'm going to do is I'm going to take some of this guy right here, this salt, I'm going to put it in the flame. And we're going to take some sugar, this guy right here, and put it in the flame. We're going to see what happens, all right? So it should be pretty interesting. All right, so first guy up, we'll take some salt, right? And we're going to put it in the flame right here. I don't know if you guys can see that. Okay. Okay, nothing much is happening to it. Okay. All right, so you see it's pretty much unaffected. Can you see that right there? Still nice, white, no problem. Alrighty, now got some sugar right here. All right, can you see that? All right, sugar, brown sugar. Let's see what happens. Uh-oh, starting to melt. Oh goodness, see that? Starting to melt already. So I didn't keeping it that long. All right, so I'm not gonna keep it at too long so it's not catching on fire. All right, see that? It's melting. Okay, see that? It's dripping. Okay, so the brown sugar, I don't know if you can see that or not, is melting. Okay, alrighty, yeah. All right, guys, so up next, what we're gonna do, we're gonna use this guy right here. It's a conductivity apparatus, okay, with the aid of a battery and some wires, right? And we're gonna test the conductivity of these guys. We already said that covalent compounds, for the most part, right, are gonna be non-electrolytes. And we also said that ionic compounds like table salt are gonna be electrolytes, right? So we're gonna see how that works with this setup right here. And all right, guys, this is my first setup. This is with pure water, okay? Notice, I'm gonna swish it. It does nothing. See that bulb right there? Okay, it's not lighting up. So water, pure water, okay, is not an electrolyte. We know water is a famous covalent compound. And if you have pure water, it will not conduct electricity. Guys, notice solid sugar, solid form, okay? Does not light the bulb, all right? No problem, that didn't work. All right, guys, next one is aqueous sugar. Okay, so I put some water in that sugar I had before, and it's not lighting the bulb either. Okay, so even though we have mobility, we're still not getting the bulb to light. No problem, non-electrolyte. Next setup, we have solid salt, all right, in here. Notice, nope, bulb's not lit, no problem. We gotta check that out, why is that? All right, guys. Can you see that? This is now aqueous salt solution. See that right there, that bright bulb lighting up right there? Bulb's lit, bam, okay. We have success. So the aqueous solution, electrolyte right there. So we're gonna analyze in a second, overview why we got the different results we got. All right, cool. Okay, guys, so let's wrap it up. Here we to analyze our results. Now, ionic compounds, right, tend to be in a crystal lattice, right? Now, this is just one side of the crystal lattice I'm showing here. Positive, negative ions, strong attraction. Now, when they're in this crystal solid lattice form, right, they'll be in a fixed position. Your ions still are charged, but they're attracted to each other in a fixed position, okay? And there is no mobility. Now, the point of the day is, in terms of electrolytes, you need mobile charge to conduct electricity. So when I put the solid salt in the conductivity apparatus, it didn't light up because the ions had no mobility. All right, so when we put the ions now, the crystal lattice, into the water, okay, made an aqueous salt solution, the ions are now freely moving all over the place, right? Okay, so you have mobile charge now, and now that's going to allow you to do what? To conduct electricity, okay? So once again, emphasis on the point of mobile charge needed to conduct electricity in order for this guy to be an electrolyte. Compounds, on the other hand, they also have attraction between the molecules, right? Okay, but that attraction, these funny arrows that I'm trying to show here, between the molecules is weak compared to ionic compounds. Also, another thing is, when we put the covalent compound, the sugar, into the water, we have mobility, right? But since the molecules are neutral, okay, even though we have mobility, we don't have any charge. So we have mobile neutral molecules, all right? And that doesn't help us if we're trying to get our substance to be an electrolyte. Okay, we need mobile charge. And if you have mobile neutral molecules, you will not get the bulb to light up. Okay, so there we go. All right, guys. As always, hard work plus sacrifice equals success. This is a very, brief, simple demonstration of ionic versus covalent and the concept of electrolyte versus non-electrolyte. Okay, you need mobile charge to be an electrolyte in terms of the aqueous or molten phase. And remember, metals are able to conduct electricity. They're solids, but they have mobile, delocalized valence electrons. Remember, electrons have negative charge and they're mobile, so that's why metals are good conductors. All right, guys, be well.